Today we're diving into one of the most exciting missions of the decade, OSIRIS-REx, with its epic return of samples from asteroid Bennu, and its extended mission, OSIRIS-APEX, where it will be studying the asteroid Apophis. This mission has the potential to unlock secrets from the early stages of the universe. Let's dig into the story and the science. I'm Ben, this is Physics or Bust. In 2016, NASA launched the OSIRIS-REx spacecraft on a groundbreaking mission to study the asteroid Bennu. This near-Earth asteroid is about the size of the Empire State Building and holds materials dating back to the early years of the solar system, about 4.5 billion years ago. After reaching Bennu in 2018, the spacecraft spent 2 years mapping its surface before doing a daring touch-and-go maneuver to collect samples to be sent back to Earth. OSIRIS-REx made history not only by orbiting the smallest object we've ever sent a spacecraft to orbit, but also by touching down on that object and collecting a sample that can be sent back to be studied on Earth. And in September of 2023, that sample made it safely back to Earth. So why did scientists choose Bennu? This asteroid is rich in carbon-based molecules, key ingredients for life. It also has hydrated minerals, which means at one point it interacted with water. Not that we're looking to make a colony on Bennu, but the more we can understand about the early years of the solar system and how Earth became habitable, the better. By studying these pristine materials, scientists hope to better understand how organic molecules developed in the early solar system, since they are key ingredients for the beginning of life. Let's talk about the physics that made this mission possible. To collect samples, OSIRIS-REx had to navigate Bennu's microgravity, much weaker gravity than that on Earth because the asteroid is only the size of the Empire State Building. This required precision thrusters and real-time adjustments in order to avoid kicking up debris. That's actually part of the reason the probes spent so much time orbiting around Bennu before actually going in to take the sample. Because with this small of an object, localized differences in density play a much more significant role in the amount of gravitational force acting on the probe. They wanted to have absolute confidence that they could precisely touch down on Bennu without navigational problems. And returning the sample to Earth wasn't easy. The sample capsule had to re-enter the atmosphere of Earth at over 27,000 miles per hour, which means it also had to endure temperatures that reached 5,000 degrees Fahrenheit during re-entry, necessitating a specialized heat shield in order to protect the sample and the capsule as they returned to Earth. What do you think Bennu's secrets will reveal? Let me know in the comments below, and if you liked this video so far, make sure to like and subscribe for more of them. Now that the samples are back to Earth, NASA scientists are busy analyzing them, but OSIRIS-REx's mission isn't over. It's now on its way to meet up with another asteroid, Apophis, and they've dubbed this part of the mission OSIRIS-APEX. So that brings up the question, what's so special about Apophis that makes it next on the list for exploration? This asteroid, discovered in 2004, made a stir when early calculations suggested a potential collision with Earth in 2029. Although we now know that it won't hit us, it will be passing incredibly close, just 19,000 miles from Earth. That's closer than all of the geostationary satellites. At over 350 meters across, Apophis is roughly the size of the Eiffel Tower. Its close approach makes an unprecedented opportunity to study a near-Earth object while it's being affected by Earth's gravity. Scientists are eager to see how this gravitational tug affects the surface and trajectory of Apophis. After delivering the Bennu sample, the OSIRIS spacecraft made an adjustment to its trajectory so that it'll meet up with Apophis shortly after Apophis does its flyby of Earth. This mission will focus on several key objectives. Number 1. Detailed mapping of Apophis' surface to understand its composition and structure. Number 2. Studying how Earth's gravity alters its surface, including the potential to cause landslides. Number 3. Performing a kinetic impact experiment. Essentially a maneuver to disturb the surface and see what's underneath. This experiment will help scientists refine planetary defense strategies and understand better how NEOs will respond to external forces. The 2029 close approach is a rare cosmic event. Apophis will travel through Earth's gravitational field, which will act as a powerful force, possibly causing some tidal stresses on the asteroid. These stresses could shift its surface material, revealing fresh regolith and even changing its spin rate. By studying these changes up close, OSIRIS-APEX will give us invaluable information on how asteroids are affected by near-miss events, which is critical critical for predicting future interactions with potentially hazardous objects. OSIRIS Apex isn't just about studying Apophis, it's about pushing the boundaries of asteroid science. From unlocking secrets of the building blocks of life to refining planetary defense, this mission is a testament to human ingenuity and curiosity. And speaking of planetary defense, I have this slight suspicion that OSIRIS Apex joining up with Apophis just after it passes Earth in 2029 might have a little more to do with planetary defense than NASA is letting on. With Apophis making this close of an approach to Earth, there are some people that are questioning how close the approach is going to be in 2036 when it comes fairly close again. What if it hits just the wrong trajectory as it goes through Earth's gravitational field? Could it be that having a spacecraft with working thrusters right next to an Eiffel Tower-sized object that just made a really close pass to Earth and is going to be making another close approach to Earth in 2036 might be a nice safety net to have, just in case the trajectory is slightly off from what we think it's going to be? And we'll be able to check our theoretical course of Apophis with the actual course after the flyby and determine if there is actually any need for making an adjustment to the Apophis's trajectory. And the fact is, missions like these help us prepare for potential asteroid deflection scenarios when they actually are necessary, ensuring the safety of everyone on the planet while expanding our understanding of the universe. OSIRIS Apex is set to turn a once feared asteroid into a huge cache of scientific knowledge. What are you looking forward to learn about Apophis? Let me know in the comments below. If you enjoyed this video, I think you'd like this book. I have an affiliate link in the description below. I do get a small commission, but it doesn't cost you any extra. For more updates on space and science, make sure to like and subscribe, and remember, keep asking questions. I'll see you on the next video.